All right, well, welcome, and we're so glad to see everybody. We're going to be running through the Gateway Mission Lockbox presentation that we have. This is the same presentation from Tuesday and Wednesday. So if you're back again, well, maybe we'll say something new. I don't
Maybe
know.
we'll try doing something a little different. We didn't give you enough time to do the whole thing, so maybe
we'll
try a little different piece of it today.
Definitely. But I'm here with Brooke, and I know Stephen is also on the call. And the three of us work together to try to incorporate some math into some of the science that we're already teaching and make this into a lockbox activity. We love doing these lockbox presentations with students. I think it's just something fun to do. But beyond something fun to do, while that's always a good thing, sometimes you need some time just to, for different things you have going on. But we always, we try to make sure that when we're designing these lock boxes that we're thinking about when the students have completed this, what are they going to now know? So we're thinking about those end learning goals in the process so that we're not just making this as like an edutainment kind of thing, that we actually have learning goals and reasons why we're having them do these. I'd also offer that the different challenges that we'll show within this lockbox can certainly be separated. I know that they're going to lend themselves to, I think, both 6th, 7th, and 8th grade standards, and they're sort of, sectioned off that way. So maybe it would be appropriate for the students, all the students that you're using, or maybe you'd want to break it apart. And with that, oh, hello, good morning. I'm going to go ahead and share my screen, and on the Purdue University doc that Bill Bailey shared with everyone, click it right on that thing. Okay, sorry, I just got sidetracked. Anyways, you're going to find a link to the Gateway Mission Lockbox Master. And this is one of the very first things that we create when we're doing lockbox challenges, is that we'll create this, and you'll see this this table that we have right here. And really this helps us, especially if we're doing paper and pencil lock boxes, but we're going to go through a virtual one as well, so that we know what are we starting with, what is the code that they're going to get, and where is that going to lead. And that way it kind of, especially if you're doing the paper and pencil lockbox challenge, you're going to have a ton of locks. And label, make sure you get all these labels on there, because then you're going to, well, where does this lock go? And you have all these combinations. But if everything's labeled and you have kind of your sheet that tells you, this, then this, then this, it just keeps you a lot more organized, and you can kind of grab and go. And yesterday in our presentation, I know Stephen and I talked about, we're going to, in the next week on Superheroes of Science on our YouTube channel, we're going to put together, we've done a conference presentation on developing lockboxes. And so we'll be looking for that. And by the way, if you've not been over to see Purdue University Superheroes of Science, we would love for you to check us out and subscribe. And like I said, we're going to be adding some ideas and feedback that we've received this week. We're going to be adding some videos in the next couple of weeks to hopefully support some of those questions and suggestions.
And I'll just add, so I kind of think of this as like the black line master. So we do have other, so part of the content and stuff, that those answers aren't here, but the code's here, like that, just the basic that you need to get through each gate is here. And then we do have the support and the kind of the information in other places.
That's right.
The content, right?
And we'll always jump back to this doc as we go through. What you're going to see under teacher links, the very first link is really for the teacher, you're going to need all the links, but for the students, that is really all you're going to need to share with the students for them to be able to do this virtual lockbox. And we'll talk a little more as we go along about some of the features of using a Google form to do this. What I've done is I've included an editable Gateway Mission. And when you click on this one, you're going to see a screen come up. And if you've never used a Google form, if you've never seen this option before, I know the first time I saw this, I was alarmed. I thought, oh no, it's some kind of virus. I don't know what this is. But all this page is doing is just telling you you're making a copy of the original, and it's automatically putting it into your Google Drive. So you don't even have to think about it. It's there, whatever Google account you're signed on under, this is automatically going into your Google Drive. And this is your editable version of the virtual lockbox. So you can definitely make changes to this. You can, we'll talk about some extensions and some modifications you can make as we go along. But you can completely make this lockbox your own, just have at it. But for illustrative purposes today, I have shared a link from the Google form that I created, and that's just an example. This is not the link that you'll want to share with students, because you won't be able to get any of their answers And back to that, if you have any questions about setting up the spreadsheet that links to the Google form, please let us know. But the idea is that you would go to your editable Google form, and under responses, you would go ahead and set up your form, and that just, again, automatically puts it into your Google Drive. And then when you share that link with students, which is right up here where you see send, and then you get the option to get a link. And then I usually shorten that, or you can email it. You can email the link as well. But however you choose to share that out with your students or through your learning management system, whatever's most convenient. When you send it from your Google form in your Drive, and you've already set up the spreadsheet, as the students complete it, I saw the guy mowing, that they're going to be able to, you're going to get their answers right there for, if that's how you're going to grade them. Okay, so here we go. This is, again, just an example of the Gateway mission, and we're using this. You're welcome to click on it. I just clicked the student link, Gateway mission, and the very first screen gives us our backstory. So we'll go ahead and read through that with you. It says, in a secret location somewhere around Cairo, a paleontologist and anthropologist discovered an artifact that predates human civilization.
You have been assigned to this top secret government project, and everything contained in these files is highly classified.
Physicists have discovered this artifact is actually a series of 3 gates that will transport people and items beyond our Milky Way galaxy.
Your team is tasked with finding a planet within these other galaxies that is suitable for both research and human survival. So as you can see, we've designed it to have a team aspect. So we were thinking about it as students working together in groups of maybe 2, 3, or 4, kind of whatever suits your classroom structure.
Yes. We have it set up right now. You can certainly change that on your own Google form if you'd like, but we're collecting the email and again, if you're new to Google Forms and you're new to how it collects responses, that's always an important one, because then, even if you're not asking for their name, you have their email and you know what responses went with which student that's submitting. And we go to next, and this brings us to our very first gate. And I love Google Forms in the sense that you can direct students to other websites. You can hot link things right there in it. And the clues that they're going to need to get through gate 1 are going to be found on this included Jamboard. And so you're going to see they're going to need to include the combination code from the Constellation word search. What's that? To pass through gate 1. And there's no way that we can get past this until we have whatever combination that is. And I'm going to click on this Jamboard. Again, you get this copy screen because now it's going to copy it for the students. They're going to automatically get a copy of this in their Google Drive, and then they're going to be able to edit this Jamboard. And here we go. Yeah, so it's going to bring us here, and we're going to see this is the student view, and then we'll be referencing the teacher view as well. And just to get you back there, that startup sheet where we began, you're going to see under teacher links the key for constellation identification. That's going to have a lot of the solutions. We went through and worked out some of those solutions for you.
And it also has the link there on the student link, the constellation identification. Mm-hmm. So that's what you're seeing now. So it was in the Google form. You were able to click on it and took you directly there. But if it's something that you want to use separate, that you don't want to use it all 3 at the same time, maybe, then you can just go to the Jamboard from this link.
That's right. That's a good point. Yeah, you can definitely section this off and just make them individual activities as well. There was another question a couple days ago about how intuitive is a Google Jamboard for my students? Like if they've never done a Google Jamboard, do I need to practice with them ahead of time? And you know your students best, but Brooke, do you want to talk about your experience?
Well, I had never used a Jamboard before. I'd heard of them. My colleagues had talked about using them in class where they would post pictures and students were able to add things. And I thought, oh, that's so neat. So I feel like I was able to catch on very quickly. And of course, our students are more technologically savvy than we are. So if I was able to catch on, I feel like they would be able to as well.
Yeah. So what we have here is we're going to, in the instructions, that we're given these coordinates for a collection of constellations, and that they need to go through and plot these points. And then after they've plotted them, they're going to connect the dots using the pen tool. So we have this pen tool over here to the left. And you can choose, there's pen, there's marker, there's highlighter, there's even a paintbrush. You can choose your ink. And if I go with this first Constellation 1, And I'm going to talk through it, but if you would like to click on that and try it yourself, you're welcome to. But Brooke, do you want to talk a little bit about the advantage to doing it this way versus like a Desmos or a GeoGebra?
Yeah, so we'll talk about a few things. So this is the start for your getting your combination code, right? So you're going to plot these different things to try to work your way to the code. So we tried to use constellations as something a little different to connect you with the science. So the Desmos, when you're plotting points, you just put in the coordinates and it plots the points for you. With Jamboard, I think Sarah kind of equated it a little bit to Microsoft Paint, which at first kind of scared me because I didn't really care for Microsoft Paint. I feel like it's a better version of Microsoft Paint, but it allows you to plot those coordinates, right? So we felt like it was important. So one of the 6th grade standards is being able to plot in all 4 quadrants, right? So having negative coordinates. So we want to be in those different spaces. And so that's kind of what we were thinking about with plotting these constellations here. So as you can see, Sarah is plotting a constellation. She's putting a nice big point there, and you're like, oh, it's a little, I don't know how we're going to get them connected. And don't worry, she's going to show you how to connect them together here shortly.
Yes. Okay. So I think I did that right. I don't know. You know how it is when you're doing it in front of the class and you're like, oh, I messed up. But we got our points down. And then we have this little hint here that when you're using this tool, if you go to the point where you want to begin drawing your line, I press the shift button on my keyboard and then I push down with my mouse on the very first dot, and then I drag it to the next dot where I want to make the line, and then I let go and I have this nice straight line here. So then I do it again, shift, push down, drag, and then shift, push down, drag. There we go. So I can connect my dots here. Again, you all here on this Jamboard, I can do all of this. The other thing I just think, like Brooke was saying, I love the idea. This is the closest thing I've found virtually to having versus paper and pencil, where you have paper and pencil for students to plot these points out on a grid paper. This is the next best thing that I've been able to find virtually, where it's the next best thing to having them plot it by hand, I guess is what I'm trying to say. So we would get all of these constellations plotted, and then the next thing we want to do is we want to send them to the next 2 slides.
So maybe you recognize it. So this is my favorite, one of my favorite constellations. So maybe you recognize it as one, maybe you don't. So that's where we kind of brought in some views of the Northern Hemisphere sky.
So we have the Northern Hemisphere in the summertime. We're kind of scanning that. And then we also have the Northern Hemisphere in November. And well, we'll get to another sky here, but can we find it? Let's see here. And oh, here we go. I see this shape right here, right, Cassiopeia. And to make it a little more obvious, let's see if I can do it yellow. Let's circle around it. There we go. But there it is. This seems to match it. And I go back and however the kids want to keep track of that name, but I would just know that, okay, Constellation 1, that looks a lot like Cassiopeia. Now, if we chose a mix of summer constellations and November constellations. And that, at the time we thought, oh, this is great. Now looking back, we think, another way we could have done this might have been to maybe choose a night sky from our location, or just from the month of July maybe, or just from one spot, so that we're not looking on 2 separate skies.
Or if the kids want to personalize it, maybe they want to find what it looks like on their birthday or something.
That's a good idea too. What we've included in the teacher key is a link to this site, Sky and Telescope. And I'm going to pull it up. I'm going to get the link here and pull it up for you just to show you. Stephen, do you want to say, so you talked a little bit about this yesterday. Do you want to say something about the Sky and Telescope?
It's really groovy.
Okay, neat. There you have it. Yeah. We can do latitude, longitude coordinates from this. I put in, the zip code here in Lafayette, where we are now. And of course, where we are now, it's daytime, so we don't see necessarily any constellations. But if we go to change the hour and then submit that, Oh, there we go. Okay. And I had to submit it. So now I'm seeing, okay, on this day, if I look up and directionally where those constellations would be from our location here in Lafayette. And it's just a really cool thing. You can go through and find some of these shapes. Here's our Cassiopeia, or Cassiopeia, however you pronounce that. Another thing that we got to talking about was we gave the coordinates for the students to graph sorry, the sharing screen
is in the way.
Yeah, I can't get to my tabs that I need to. There we go. Okay. If I go back here, we gave the coordinates for the students to graph. We think another really cool modification that you could make would be to give the students the shapes of the constellations, maybe not even overlaid on a grid, maybe just the shapes of the constellations like what you see here on this site, and have the students decide where they will, what those coordinates would need to be able to plot those constellations correctly. So kind of reverse engineering the constellations in a way.
If you're using that as a code, you will have to give them the first point where to put it. Otherwise, the code will be, different for every single one.
Yes. Yeah, that's a really great point. Yeah. Especially, yeah, definitely if you want to use that as a code, you'd have to have a reference point so that it wasn't like random numbers that you were coming up with all the time.
Or you could even give them like 3 of the coordinates and ask them for the other 2, or you could even have them, if they are in the coordinate grid, you could have them reflect it like,
Ooh,
oh, we're in a
point
different
too,
time of year. Now it's flipped down here. So your coordinates kind of adjust that way, and they can look at how did the X and Y coordinates change in terms of their signs. You could also have them scale it like, okay, we got a telescope and we can look closer at it. So
yeah.
if we're going to zoom in 10 times or something, what would it look like? Where would the coordinates be in this case? So I think there are lots of options for it. Now with Lockbox, like we kind of have it in our own little box, right? So we're doing it this way, but we're just trying to give you other ways to think about it, to try to kind of support the student learning and tie in the math and science together.
But if you thought about it ahead of time, I still like the idea of like reflecting it or telescoping in. And so so scaling it out a little bit so you know where you want them to end up and you know what that final coordinate should be. And maybe you even, give them the shape and number the coordinates and just say, okay, if we start and this one's here, what would this coordinate be? I don't know. What did I say when they magnify or take it out?
Dilate when it's dilated.
Yeah, like a dilation. That would be kind of cool too. Those are just neat math twists. I think
of course, you're gonna have some kids who are like, well, like the Earth isn't flat, so or the sky, everything is like curved and all that. So I think it could bring in good discussions too to think like, oh, there is a Z-axis, and we could think about it, what it would look like in that. I mean, lots of different good discussions I think that could come from.
Yeah. All right, so let's say we plot all of our constellations, we've got these, we've identified the names, and so now what the students are going to see is they're going to get to this word search, and their directions are to find and shape the names of the constellations that they plotted from slide 1. But there are a lot of constellation names within this crossword. And so we have here, some of the constellation names will be used more than once, and that's just so that we could, because from this, we'll go ahead and jump ahead here. They will get to this point. They will have their names. So we know like one, like what we plotted, Cassiopeia. And then we have the other ones that when they search for those spelled correctly, because of course, when we go through that, we did write out some of these spelled incorrectly just to throw them off and be mean.
You see some Boilermakers, you see some other stuff in there.
Right. Ice cream. But what we see is this nice code here. This is the code that we're needing for our gateways. Stephen, I hear you. What were you going to say? Oh, no, it's just
nothing. I was just enjoying looking at the different words in there.
Oh, okay, right. I think our I am the most entertained when we have middle school students on doing some of our Lockbox presentations, because I feel like we have a word find in most of these where they have to come up with a code, and they are so entertained by some of the things that's spelled out. Like Stephen likes ice cream. What? And we do have a link We shared the link in the doc that Bill has with all of the links to all these presentations and everything. Like we said, the link to our Gateway Mission Lockbox Master, but also a link to the spreadsheet that Stephen used to build the word search. So if you see anything that you would like to edit or change, or maybe you want to make a new word search and you just wanted all the columns and rows, you know, already adjusted, we have that shared as well. So yay, we got our very first code, and this took us to gate 2. Congratulations, yay. And here's our next clues that we have for gate 2. And now we're switching topics, where before we were looking at coordinate plane and graphing coordinates and constellations. Now we are switching into geologic timescale. And for this one, the students are going to need 2 separate things. We're going to need the distance in centimeters to the first land plants. I'm not sure what that means yet. And also, we're asking for a ratio of some sort that we're looking for here. So again, this is going to take the students to a new Jamboard.
And again, similar to the first activity or the first gate, in that master, the Gateway Lockbox Master, you can access this Jamboard without going through the Google form. So if you want to get to it separately, you can get to it that way.
Yeah. So we see now our geologic time scale. We have today and then all the way to Precambrian time all listed. And this says that the second gateway that we are is a literal gate that measures a length of 4.6 meters. And it contains symbols along the way representing events in different eras of Earth's 4.6 billion years of geologic history. And the idea behind this little note that we have is that we want the students to understand that 1 meter is going to correspond with 1 billion years. And that's a huge number for students to be comfortable. I think, first of all, just to be comfortable with those. I know even when I was teaching the high schoolers, I think just getting all those zeros down, it's difficult for them to comprehend how large that number is. And so we're saying, okay, well, we're going to begin with finding the distance along this gateway in centimeters to the symbol for the first land plants. So I'm beginning with my time today as 0. How long until I get to the land plants? I'm looking down, and here they are. And it's right at where we would call 440 million years. So I've not quite to 1 billion. I've only reached 440 million. And so for this, I know that it would take me 44 centimeters.
So we're thinking about this in lots of ways. So one way you could have students create a timeline that maybe marks more than just the first land plant. So you want to give them a piece of receipt paper that's 4.6 meters long. You could think about, oh, I want to have you mark these different things. We're starting just with this for the gate, and then you can always adjust it again from there.
And Stephen had a presentation yesterday specifically about geologic timescale and a lot of those activities. And that, if you're interested in that, that link will be posted probably by the end of the week, I'm guessing, or next week.
It's in the playlist.
Oh, it's already in our playlist. Okay, so if you missed yesterday, or if you're new today and you're like, oh, geologic timescale, I wonder what that is, you're welcome to go to the playlist. And again, that link to the playlist with all the videos is at the top of that Google Doc that Bill Bailey has shared with us. Great. So 44 centimeters, that's what we need from today to the first land plants. 44 centimeters, great. So I go to this next one, I say, okay, slide 2 is how I get my second answer. Imagine if the time it takes for the first land plants to appear continually repeats itself. How many times would it completely repeat itself before bacteria are first found? You want to talk about this one, Brooke?
Maybe. So something this kind of, I guess, stems from the idea that sometimes students have a really hard time thinking of large numbers, right? Mm-hmm. And so we're thinking about these values like even 440 million years. What does that even mean? I don't know. But so we wanted to think about kind of this idea of repetition and thinking about ratios, right? So kind of maybe that will help them think about the different era or the different time spans there. Mm-hmm. So the first bacteria we see down there at 3.5 billion years, or 3,500 million years. Like that's
you know, I'm not even going to live 440 years, let alone 440 million years. So that's just way beyond my comprehension to begin with. And then to think, okay, so how many of these 440 million years am I going to cycle through to get to 3.5 billion. I mean, that's just,
So how are we going to think about that? Well, we want to think about how many of those 440 million chunks are going to be in there. So we can think about it as a ratio, right? So this idea of 3.5 billion years and 440 million years, and how many of those are repeat. So how do we get there? Well, we're going to do some division, right? So this idea of ratio coming into play, that's where the mathematics is coming in. So we would take 3.5 billion divided by, or sorry, we want to turn to centimeters first.
well,
I
really,
guess
we
we
could
don't have
probably
to
do it either
because,
way.
Functional analysis allows for either. If you want to think about where to be on in terms of a timeline, then we would go like 44 centimeters and then 3.5 meters, right? So you're thinking about how many of these 44 centimeters are going to be in this 3.5 meters, right?
Or 350 centimeters if you wanted them. Yeah, well, either
in the
way.
same units.
Yeah.
Yeah, we wouldn't want them in different units.
Right.
Oh, goodness.
Well, but we would have them. We
Or
could have them
3.5 and
convert.
0.44. Lots of different mathematical ways to do that.
So there we go. We've got our 350 centimeters, let's say, divided by 44 centimeters. But this is really the fun part, right? They get this 7.95. Great. Okay.
Yay.
Found this, and we like this. This is a unit ratio because we had our one time period and how many of those complete repetitions for that one time period. So I say 7.95 sounds like 8 to me. So I'm going to go ahead and put in my 44. Maybe.
There we go.
There.
We're good.
Oh, we're good. Okay. Sorry about that. And then I said, okay, what I say? 7.95.
That's 8. 8 times.
Great.
We got it. Okay, so what happened? Did we we rounded. Okay, why are you asking me if I rounded? I rounded. So let's look back and see, did we misinterpret something?
So how many times would it completely repeat itself before bacteria are first found? And now I got tricked a little bit on the wording. And we like to have students think about rounding. Definitely. That's definitely something that we have, round to the nearest whole number, round to the nearest thousandth, wherever you're having them round. But in this case, they're thinking about rounding a little differently.
So we want to think about completely repeating itself, right? So typically we do round to the nearest whole number. 7.95, I would need 8, done. Well, when I'm thinking about complete repetitions, that's not rounding up to the nearest whole number. I would have 7 complete repetitions and then 95 hundredths of another cycle, right? So I wouldn't have that full complete cycle yet. So we would only have 7 complete ones.
Fix that. And boom, it takes us to gate 3. Yay. And congratulations, you reached your final gate. We have here this holographic projection of a solar system. We have 3 different planets, and we've got to determine which of these 3 planets will make an acceptable research location. So the idea here is that when the alien sun rises on each of these planets, that different amounts of energy are absorbed or reflected based on the surfaces that we find on these planets. So each of these locations has 2 really distinct fauna that we talk about. We have a light field and a dark field, and the dark fields are very dark and absorbing, and the very light fields they're light and they reflect a lot of that energy. And we know from what happens here on Earth that difference between the dark and the light and all that energy getting absorbed and energy getting reflected, that we can create these convection currents in our atmosphere. And that from these convection currents, we have a lot of energy, and a big difference between those. We get these shear winds coming off of this that can be fairly destructive. And we want to make sure that we choose the correct planet that will both support the research that we're doing, support our equipment, but also create an environment that's going to be conducive for living, that we want to be able to live and live on this planet. This ties in with our air pressure and the session that's coming up later this afternoon. And Stephen, you want to say just a shout out about that one?
It'll be groovy too. But we're going to do, because you guys whined and said we should, the lockbox, the weather and climate lockbox at the end of that one. So the last part of that will be going through and explaining that resource also.
Definitely. And so, this is an opportunity for a new lockbox as well. Beyond this one, we have a completely different one. It's actually one that we did with Brooke. And I think that's what kind of prompted us all to think, we should make a new one because your students seem to really like doing that one.
My pre-service teachers just fell in love with it. They were.
Yeah, it's a fun one. So that'll be at 1 p.m. Eastern today. But here is our final gate that we have these 3 planets, and we are supposed to calculate the ratio of light field to dark field air mass volumes. But what we're given is a diagonal and the length of one side for these 2 fields. We're also given the atmospheric height for the planet.
So when we think about the mathematics involved in that, right, we want to find the air mass volume. So I need to find the area of the base and then the height of the atmosphere. So I know the height of the atmosphere. I don't necessarily know the area of the base because the diagonal doesn't give me length or width. So I have to do the Pythagorean theorem in order to find the other dimension of that rectangle so I can find the volume of it.
And for that matter, we also worked in the idea of Pythagorean triples into this because we didn't want to make it too crazy numbers because we wanted students to be, even our 6th grade students to be successful with this and not, freak out if they saw radical. And so what we did is now when we were talking about this, Stephen was like, he just looked at us and he's like, you got to tell me, remind me what Pythagorean triples are. And we laughed. And then, and we said, okay, well, your Pythagorean triples are where you have whole numbers, right?
Whole number side lengths and your right triangle.
Yeah. And so, for example, a 3, 4, 5. So we have, 3 squared on one side is 9 and 4 squared on the other side is 16 and 9 plus 16 is 25. So if we know a squared plus b squared equals c squared, right? And so the square root of 25 is 5. So that would be our 3, 4, 5. That's an example of a Pythagorean triple. And you can Google them. I mean, there's just a lot to choose from. So we chose some that we thought would make for pretty good fields and also gave us some interesting ratios. So we used the Pythagorean theorem. We found our missing side. Then we found the area. And then we multiplied by the height. And we got our air volume for the light field and our air volume for the dark field. And we want that ratio between light field to dark field air mass volumes. Now, back to our kind of roadmap here for the Lockbox Master. We have those solutions for you under the teacher link, The Key. And when we go to the Google form, what the students, once they work through all of those calculations, they're going to order those, the lowest calculated ratio, which ended up as 1. And it does work out nicely to 1. And the second lowest was a 3. And then the highest calculated ratio was a 5. And now this is for all the money here, where the students have to decide which planet would they choose for this research outpost. And they get to choose planet 1, planet 2, or planet 3. That is not necessarily the order that they're entering it in on the Google form. So they might be thinking it does work out, though, that the ratio of 5 does correspond with planet 3. And I've been doing this all week. Maybe we want to start with planet 3. I don't know. Maybe we're impressed by a ratio of 5. So we go there. That's my answer. I'm going to planet 3. And oh my goodness, game over. What? I did not use Stephen's original description. He wanted to say something like, you've killed all humanity. Your math is terrible, this and that. I think I'm paraphrasing, but the ratio of air masses on this planet is too high. So we're doing a little bit of critical thinking now. We have these air masses. What does that even tell us? What am I actually trying to do? Well, the goal of this whole mission is trying to find a planet where we're going to be able to do research and live, that we're going to be able to inhabit this other planet. And we got to think, or we're hopefully going to be connecting that to, we want a ratio as close to 1 as possible, because then we're not going to have these wild energy differences, and the shear winds off those convection currents will be in a normal range that we can survive in. In this, if the ratio of air masses is a 5, that's way too much of an energy difference, and you're not going to be able to live on this planet, let alone do research. So if we go back, well, let's retry this. I still have my 1, 3, 5, which I like, but maybe I want to try planet 2. So I go to, oh my gosh, I went, planet 2 is the answer. And planet 2 does correspond with the ratio of a 1. And so again, we know that that ratio of 1, as close to 1 as we can get it for that ratio of light field to dark field, is going to be, really create that ideal environment to both live and do that research. And just for fun, because if I've lost and now I've won, what on earth would what would be the third choice? I don't even know. Go to planet 1. And it's not ideal. All right. So we still see a little person here. walking around, but looks like our research is just really getting blown away here.
Very limited.
Yeah, the air masses are still going to be too high because that ratio of 3 is a little too, it's not close enough to 1. We could still probably survive, but it's going to destroy our research equipment.
So if you're thinking about these as like 3 separate activities, again, a way that you could modify this one if you feel like it needs to be something, you want to add something to it, you could say, give maybe the air mass volume for 1 for like the dark field and tell them what the ratio is, and then they would have to find the air mass volume of the second one. So different ways, or have them kind of describe different triangles, find a different Pythagorean triple, or maybe one that's not a Pythagorean triple where they're finding the area and then I'm using some radicals. So I think there are other ways you could modify that if you aren't thinking about it as one complete activity, as the lockbox is the whole thing, right? As if you want to separate them into 3 things.
Absolutely. And that's a really good point too. Yeah. If you want to make it its very own activity and just use that one, I think that's a good point for that.
Or maybe have them design their own lockbox mission.
That's right.
Where it has different parameters.
Well, and even, whether you're reverse engineering the constellations or you're choosing your own Pythagorean triple or your own, I have this ratio and this is the air mass volume for this one. What would this one be? When the students are creating those and then they share it with other students, just to have their peers try to solve the problems that they're creating. I always thought that was really important because you can learn how to solve the problems, but then can you write the problem then? Because now you really know how to do these questions. If you can then write them and have your peers get answers that make sense.
Yeah, you're just showing a complete different level of understanding, right? When you're able to do that. Okay.
Yeah.
Where are we at now?
So we've made it through the lockbox.
A couple of highlights. So I want to make sure, just to reiterate what Sarah said earlier, that student example is just an example. And so if you send your students there, you're not going to get the results from it. So remember, you want to create your own student example, right?
Yeah.
Otherwise, Sarah gets it all. I don't
know. I don't mind. They can use that one. It's whatever you want. If it's just to have them go through and do it, but my guess is you'd want to
have your own.
Yeah.
Okay, so it's now time for questions.
Yeah.
Yeah. So thoughts, questions, anything you guys want to share? Or want to talk about so we did it with virtual. So this is all virtual. You didn't have to have a lock at all or a box. But some of you are going to, or maybe have already received your locks or are going to receive locks or put them in a lockbox. So you want to talk about maybe how that would look? Or...
Yeah, absolutely. So you don't even need, with some of the kits, we sent a box and then a directional lock because I love directional locks and I just cry about it all the time. I'm like, we need directional locks. What else can we put a directional lock on? And everyone's like, oh, Sarah, just stop at the direct. But really, you don't need locks or anything special to do any of these. And definitely each of these could be printed. You could even print the Google Jamboard and hand it to the students to do. You could do this with an empty drawer or an envelope or, a file folder. You don't have to have anything fancy to be able to do these lockbox activities. It's really more about the students finding that challenge and being able to show, hey, I got this answer and it's right. So now I can get this next puzzle and move on to the next,
And I think we were kind of thinking that the first lock would be at the 1741. Excuse me. And then you could do the second one with the 44 and the 7, or it could be separate. Like you could do 1 for the 44 and 1 for the 7, right?
Yeah.
And then the same with the ratios. You could kind of split them up or put them all together.
Okay. Someone had asked about the less expensive lock boxes.
Okay.
We certainly don't endorse any official lockbox type place. I know there's one place in particular that does. I don't think I could say that. But we've bought this stuff and it was junk. They fell apart. The locks fell apart. They were terrible. The best place to get lock boxes is anywhere that sells tools and stuff like that. It's we literally went to I got some at Rural King, Menards, Lowe's, Walmart, all these places. We went there and got the inexpensive toolboxes. They were bigger, they were sturdier, They did a better job. We love them. We use them every time we teach these. And we don't use the ones that we bought as a lockbox kit when we first started doing these years ago. And I think those locks didn't even make it like through one semester. And with us only doing it a handful of times. And so, but we ended up getting locks. I mean, you can get locks at all those places. You can get locks online. You can buy them everywhere. It's, you know, Amazon, the big conglomerate there, seems to have a monopoly on a lot of cheap stuff. But yeah, box wise, yeah, just
Yeah.
get you toolbox stuff. That works so much better and they're so much less expensive.
Well, not to mention those actually hold a sheet of paper, right? Like an 8.5 by 11 sheet of paper. The company that we purchased a kit from wouldn't even hold a standard sheet of paper. Like
Post it.
are like, how? What are we supposed to do with this? So yeah, it was inconvenient. We were disappointed.
And we always have, she mentioned envelopes, using envelopes. We always have at least one where we do have envelopes in them. And if we have some teachers that don't have the boxes, and what they do is they have the stack and they come up and they show the gatekeeper, which starts off as a teacher and ends up being the first group that gets done. But the gatekeeper, their code, they have the right code. Okay, here's your envelope, your next mission, go. And so you could do it that way. We have the large manila envelopes with packages of stuff, which we'll show you in the next session when we start talking about the graph matching stuff that we have in the climate one. But so we like having larger things in there, and little ones just don't play. And someone mentioned that they've done the envelope lock boxes. They do still enjoy it. They still get a kick out of it. The challenge is still there. It's fun. And we slowly bought more and more locks as we went, and so we got to the point where, because we have like 4 of these we do now, right? And so we have a container that has all the locks that we need for our climate one, a container for all of them we need for our elements one, and so we slowly built up our lock collection so that we didn't have to change our locks each time we changed something. But so that was convenient for us to be able to do that, but it took us a while to slowly get those.
I may have done it one time where I used a map of the school and put a coordinate plane over the map of the school, and the different clues were in different locations.
Yeah.
So like maybe a teacher in a classroom at whatever, like 7, -3, like they had to go to that teacher and get the next clue. So lots
That's
of
cool.
variations, I think, of it.
Mm-hmm. Good deal.
And I like the escape room idea behind that too. We've done that. We've actually had a custodian come in and to like walk in and shut all of our blinds as we were getting ready to do one. We asked, "Hey, come in, shut the blinds, and tell them, hey, we have this top secret mission. You're in lockdown." And it's like they told us the whole place was in lockdown. We couldn't move and leave until we figured something out. And your other staff enjoys getting in on things like that, getting a kick out of it. No, what custodian? It was the tech guy, wasn't it? Sorry, it was the tech guy.
Oh yeah, it was. Well,
Yeah,
yeah,
it was
I
Matt.
think it was.
It was
the tech.
Matt, the tech guy.
Yeah.
But so yeah, you gotta have fun with things. Just have fun with this stuff. And remember, if you're having fun and enjoying it, getting a kick out of it, the kids have more fun with it too. They buy those stories. When I was teaching the elementary, I did this huge long crime scene unit thing. I had the school liaison officer kick it off for me. He came in, there's crime scene tape around the room, and he came in and kicked it off. And you should have saw my students. It's like it's some of my higher achieving ones that leave. They were I think they were the ones that were like hook, line, and sinker most. I had kids literally shaking, telling other kids, "We're really gonna do this," and stuff. It's like you could have so much fun with the kids.
That's so fun. No, you can use whatever. You could use a 7-digit code if that's what you wanted to do. And if you let's see, ooh, yeah, and ammo boxes. That sounds like a great idea. That would look kind of
I've
cool,
never heard of
anyways.
any.
Yeah. Well, I'm going to share my screen again, and I'll pull up the Google form just in case anyone, if you weren't here yesterday, I can, or if you were and you want to see this again. When you are editing your lockbox, so if you go to So you can see I'm on the copy where I can edit and make it all my own. We do a, let's see here. We do a response validation. So if we're the very first one, we have a 4-digit code. What you're going to see is I made this a short answer. And then down here, I made it required. And then next to it, it has description and response validation. I went ahead and checked response validation. And then I have some choices now. I can go with a number. I could go with a text if I wanted them to enter a certain text. And whatever text letters if it contains, if it doesn't contain, if you want them to put a link, maybe a bit.ly link that you create or something that you want them to find to move on to the next one. I did number. And even with number, you have a lot of different choices. I really like the idea of using greater than or equal to or less than or equal to. And I think especially this can really tie in nicely with graphing and some inequalities and things where you could have questions designed for that. But we just did equal to, and then we just typed the number that we wanted it to be. So you could type, I don't know if there's let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, it looks like you can make it whatever length you want it to be. What was ours? 1741. And then you also have a custom error text. And this is nice to be able to give them a hint if they're not getting it correct. What do they need reminded of so that they can get this? And I think for this first one, I just did like a blanket, like, oh, try again or something. But for our gate 2, when we did this response validation with the rounding one that we talked about, that was our error text was, are you rounding? So I'll go ahead and stop. But that's just one feature that you have on your Google form. Oh, yeah, and let's see here. Periodic table version. Yeah, so for the periodic table version, absolutely, you can email me. I can send you the link, but Stephen's going to have that posted on the Lockbox site. And I don't know if you want to copy that in again. We'll have that in the next week. It's done. I presented on that. That was what we did last year. And so we just have to put the link on the webpage.
And I think one of the questions was about the size of the box.
Yeah, so that's what I was looking for, Brooke. That's what I was looking for. All of our stuff's in the other room. We use all different sizes, as long as whatever you want the kids to get. Bill put it on it too. As long as whatever you want the kids to grab and pick up fits in the box, it's fine. I mean, sometimes some of ours are half sheets, literally just a half sheet with stuff on it. It gives them clues to whatever. And so as long as whatever you want to fit in there fits, then you're good to go. You can use anything you want. We have a drawer, a locked drawer that we unlock it for this, and I'm a little anal about organizing. I like labels, and so it's all the drawers in the lab are labeled, and one of them is literally labeled pandas. And so at the end of one of the clues, it's like seek the wise panda for your next clue, and so they have to figure out where that would be. And then, there's a drawer called panda. And they just open that drawer and grab the next paper out. So it could be a variety of things. Try to think outside the box. So sorry.
Oh, man.
Oh, that's a great way to end it.
On that note, I think it's lunchtime. Well, for us, it's lunchtime.
So thank you.